Alright guys, we've been able to derive the functions of the angle 45 degrees, the sine of 45 degrees, the cos of 45 degrees, and the tangent of 45 degrees. Now we'll be considering the angle 30 degrees and angle 60 degrees. In this angle 30 degrees and angle 60 degrees, now the mathematical assumption of an equilateral triangle is considered here. Let's look at this. This is an equilateral triangle. We all know that the total angle of an equilateral triangle is equal to 180 degrees. So this is an equilateral triangle right here. And how many angles do we have here in an equilateral triangle? We'll have the first vertex here. We'll have the first angle. We'll have the second angle, and we'll have the third angle. So we're making a total of how many angles? 3 angles. So now if we see that in an equilateral triangle, the total angle of an equilateral triangle is 180 degrees. That means since it's made up of how many angles here? 3 angles here. That means it should be 180 divided by 3. So each angle here, if 180 divided by 3, it will be 60 degrees. That means each angle here will be what? 60 degrees. Here will be 60 degrees, and here will be 60 degrees. Remember, we are still on the derivation. Now, let's assume all the sides to be 2 units each. So here is 2 units each. Here is 2 units. Here is what? 2 units. So that is it. All of these sums up to what? To 180 degrees as an equilateral triangle. So, but technically, looking at this illustration here, what if we bisect this equilateral triangle into 2 equal parts? So on bisecting this equilateral triangle into 2 equal parts, technically there is something that you have to observe, or you will be observing right there. Looking at this, look at this. You find out that this angle is divided into 2 equal parts, right? This angle now is 60 degrees divided into 2 equal parts. That means here is 30 degrees and here will be what? 30 degrees. That's the number one thing. Secondly, we have a right angle here, because if we take one part of this, if we take this part out, we have a right angle. Are you getting me? If we take this part out, it will be equal. It will be equal to 90 degrees. Let me make it more clearer to you. Let's bring this illustration out. Let's bring this illustration out here. That is me taking out one part of this equilateral triangle. Since I've already divided into 2 equal parts, let me take this part out. So since here I said the division here makes here 30 degrees and here, so that means here is what? Here is 30 what? 30 degrees. Are you getting me? The half of it is 30 degrees. The half of this is 90 degrees. Half. 90 degrees plus 90 degrees, 180 degrees. One part of it is what? Is a right angle. That is 90 degrees. So we'll have a right angle here when we take this part out. Remember, this is still what? This is still 60 degrees. Are we following? Now look, considering this part, we have 2 units from here. So here will also be what? 2 units. Now, another thing you have to observe is this. You know that the whole of this side is 2 units. Now, you dividing it into 2 equal parts, that means this part will be 1 unit and the other part will be 1 unit. That is to say that here will be what? 1 unit. Is that clear? So we'll have 1 unit. Remember that if we are doing anything that we are doing here, anything that we need to derive here, we need to get the whole sides. But to technically bring out this part of the equilateral triangle, where we'll have a right angle here, and then we'll have this angle as 30 degrees, and we'll have this angle as 60 degrees. Now from what we'll have here, this is 2 units and this is 1 unit. There is nothing we can do here if we did not get all the sides. Now we know this side. We also know this side. What about this side? Taking back to what I introduced to you while we are deriving the values of the 45 degrees here, I told you that in a right angle triangle where we are looking for the unknown side, we apply the Pythagoras theorem. So whenever we are looking for the unknown side in a right angle triangle, remember Pythagoras theorem. So the theorem of Pythagoras says that the square of the hypotenuse side is equal to the sum of the squares of the other two sides. Now, looking at this is the base angle here. If this is the base angle here, this is the opposite, Abi. If this is the base angle here, this becomes the opposite. So the opposite varies depending on the side facing the what? The base angle, just like I said before. So now, looking at this here, we have the hypotenuse side as 2 units. We have this side as 1 unit. What about this side? So let's apply. The hypotenuse side, which is 2 units, we can say that 2 units squared, which is the hypotenuse side, is equal to this 1 unit squared, which we don't know. Now remember that here that we don't know, this place that we don't know, we can just identify it as x or y. So let us use x. We don't know this side. So plus this side that we don't know, which is x, so we have x squared, right? So applying this properly, we have that 2 squared will give you 4, but 2 squared means 2 times 2 is equal to 1 squared, which is 1 plus s squared, right? Good. So x squared is what we are trying to determine. The value of x is what we are trying to determine. So but at this point here, for us to get this value, we have to subtract 1 from both sides or move this 1 over. So moving this 1 over, it changes to minus. So we have 4 minus 1, which is equal to what? X squared, right? So 4 minus 1 already is 3. So we can say that x squared is equal to 4 minus 1, which is 3. We are not done. For us to get the value of x, you know what to do. We take the square root of the what? Both sides. So taking the square root of both sides, you have that x here finally is equal to what? Square root of 3, sort of 3. Now we've been able to derive this particular side as what? As sort of 3. I don't know whether there is any question here, but I hope it is very much understandable. So we can replace here with sort of 3 because the value is already determined as sort of 3. So with this, all these sides being determined now, it is now very much easy for us to determine the sine of this function, cos of this function, tan of this particular angle and this particular angle. So we can be able to derive all of these things very, very easily without stress. I'm going to start with the first angle here, which is angle 30 degrees. I'm going to start with this particular angle 30 degrees. So let us consider, if we are considering angle 30 degrees, that's making angle 30 degrees becomes the base angle here. So since it's the base angle here, that means it's facing here. Abi, this side facing here is the opposite. Anything we are doing, we're also relating it to this, our introduced functions here. So if this is the base angle, since this base angle is facing here, it automatically makes here the opposite, right? So let us consider the sine of 30 degrees. Now considering the sine of 30 degrees, under the sine of 30 degrees, we consider this. Sine theta is equal to what? Opposite all over what? Hypotenuse. So we have opposite over hypotenuse for sine of 30 degrees. And here now, what is our opposite? Our opposite is what? Is 1 unit. Remember, because it is facing the 30 degrees here, so it's the opposite. That means it's 1 unit. It's here labeled 1 unit. So we are going to just substitute this 1 unit for the opposite. So we have 1 unit. What about the hypotenuse? Now, hypotenuse is what? 2 units from what we have here. Is that okay? So we have 2 units. That's all. In that case, sine 30 degrees equals to what? Opposite over what? Hypotenuse. And what is our opposite? 1 unit. What is our hypotenuse? 2 units. So what is sine 30 degrees? 1 over 2. Now, in one way or the other, you see sine 30 degrees while you're, solving a problem. Probably come across it in your wife or jam pass question. Just know that sine 30 degrees is 1 over 2 or 0.5. So when you point this in your calculator, you might get 0.5. 0.5 is the same as what? 1 over 2. So why using calculator when you know that sine 30 degrees is 1 over 2? So you have to know it. Alright, so what we have to do now is 1 over 2 now we impute it here. So that means sine of 30 degrees is 1 over 2 derived. Next up, we consider the cos of 30 degrees. So what about cos of 30 degrees? So what about cos of 30 degrees? Remember, the cos from our function here is what? Adjacent all over hypotenuse. So we'll have adjacent over hypotenuse. Adjacent over hypotenuse. So what is our adjacent from here? This is the adjacent. If I'm correct, this is adjacent. So what is the hypotenuse? This is hypotenuse. So we have that cos 30 degrees is equal to what is adjacent here? Sort of 3. And what is the hypotenuse here? 2. Simple. So whenever you're asked what is the cos of 30 degrees, you tell me that cos of 30 degrees is simply what? So 3 over 2. Simple. What is the sine of 30 degrees? Sine of 30 degrees is what? 1 over 2, sir, or what? 0.5. It's that simple. And at this point, I don't even think we need to do anything anymore. It's just sort of 3 over 2. So I will substitute it. I'll just write sort of 3 all over 2. So it's that simple. So having gotten cos 30 degrees, we'll consider the tangent of 30 degrees. So tangent of 30 degrees. So what is the tangent of 30 degrees? We also consider this function here. Tan is equal to what? Opposite all over adjacent. Opposite all over what? Adjacent. That is tan 30 degrees. Opposite over adjacent. Okay. So what is the opposite? From our function here, remember we are basing our concentration on what? 30 degrees. So our opposite here is what? 1 unit, and our adjacent here is what? Is sub 3, right? So that means opposite is what? 1. So write 1, substitute. Adjacent is what? Sort of 3. Now mathematically, we cannot leave our answer like this because we are having an irrational number as the denominator. Just like I said before, we can't leave it like this. So we have to rationalize. So by rationalizing, we know what we do when we are rationalizing. We use the value of the denominator to multiply the numerator and the denominator. Simple. Why? The major reason there is for us to eliminate these words, this sort here. So you see how it works. So we have 1 all over sort of 3 times sort of 3 divided by sort of 3. That's what we mean. We are using this denominator now to multiply the numerator and denominator. So applying this right here, we have 1 times sort of 3, we give you sort of 3, and sort of 3 times sort of 3, we give you square root of 9. Square root of 9 is what? 3. Simple. So looking at this now, we've been able to eliminate the sort from the denominator part. What do we have now? We have sort of 3 divided by 3. It's very simple. Very, very simple. So if they now ask you, what is tan of 30 degrees? Simply tell me, sir, tan of 30 degrees is what? Sort of 3 divided by 3. Simple. So I'm just going to put it here. So I have sort of 3 divided by 3. Derived. We have sine 30 degrees as what? As 1 over 2. And we have cos 30 degrees as what? So 3 over 2. And we have tan 30 degrees as what? So 3 over 3. Simple. Next up, we consider the 60 degrees. But I hope this is gotten. We are almost done. So chill. Don't panic. Okay, so now let's move over to sine 60 degrees. Now we are no more considering this 30 degrees, but rather we are considering 60 degrees as the base angle. So because of this, the opposite side will now change. Here is no more the opposite side, but rather here is the opposite side because it is facing the what? The base angle. So okay, so at this point we consider the sine of 60 degrees. And what is sine? Sine from here is opposite over hypotenuse. So I will just say opposite over hypotenuse or sine 60. What is opposite? Opposite here becomes sort of 3. So I will just impute sort of 3 here. And what about hypotenuse? Hypotenuse side is what? 2. So that means that sine 60 degrees is what? So 3 over 2. And that is on period. So I'm just going to substitute here to have sort 3 over 2. Very simple. I say very simple. So let us continue. Okay, let me clean up. Can I? Yes, I can. Oh good. So now look at it. We consider the cos of what? Cos of 60 degrees. So let's say cos 60 degrees. Cos 60 degrees. Now remember from our function, cos is what? Adjacent all over hypotenuse. So if cos is adjacent all over hypotenuse, what is our adjacent here? Our adjacent here is 1 unit. And our opposite, our adjacent here is 1 unit. And our hypotenuse here is what? 2, right? So cos from our function is what? Adjacent over what? Hypotenuse. Adjacent all over hypotenuse. Where our adjacent is here is 1 and our hypotenuse 2. That means cos 60 degrees is equal to 1 over 2. Simple. So whenever you hear cos of 60 degrees, somebody come and ask you, what is cos 60 degrees? Tell the person that cos 60 degrees is 1 over 2 or 0.5. So that is it. So I always know that sine 30 degrees is 0.5 and cos 60 degrees is what? 0.5. They have similar value. Do you understand? So that's just simply what we have there. So I will impute it here. 1 over 2 for cos 60 degrees. Now let's consider tan of 60 degrees. So tangent of 60 degrees. What is tan 60 degrees? Consider our function here, opposite all over adjacent. So we just write it out, opposite over adjacent. So tan 60, tan, function of tan is opposite over adjacent. What is our opposite here? Our opposite here is sort 3. So we can have sort 3 divided by, what is our adjacent here? Our adjacent here is 1 unit. It's very simple. Very, very simple. I don't know. The God that created math really did a very great job because math is so simple. But math is food. With math, I don't even think you need to get hungry, honestly. So at this point, when we have sort 3 divided by 1, so 3 divided by 1 is what? Is sort 3. Because anything divided by 1 is still that. Right? Your head divided by 1 is your head. So now we have sort 3 divided by 1. We give you sort 3. It's very simple. So at this point, we can say that tan of 60 degrees is equal to what? Sort of 3. We have derived everything we need. So at this point, we are done. This is just the simple way of deriving the functions of all of these special angles. The values of all of these special angles have all been derived. So with this method now, and if you can calm down, study this method very well, you see that you will not be having difficulty even if you are asked to write an exam without a calculator. So with all of these things now, you can derive most of the values and have it off hand, that you can enter the hall, meet any question involving trigonometric problems with these special angles, and you will just solve it very, very simple without stress. Now, in our next class, I am going to teach you how we can use this knowledge in solving most of the trigonometric problems or trigonometric related problems. You will see how we can just swiftly solve them knowing these values. We don't need our calculators anymore because your brain worth more than any calculator in the world if you develop it. Have a nice day.